This is Lesson 6.2, Parallelograms. Your objectives are to recognize and apply the properties of the sides and angles of parallelograms, and recognize and apply the properties of the diagonals of parallelograms. A quadrilateral with both pairs of opposite sides parallel is a parallelogram. Here are four important properties of parallelograms. Opposite sides are congruent. Opposite angles are congruent. Consecutive angles are supplementary. And if it has one right angle, then it has four right angles. So keep track of all the properties of it and use those as we work the problems out. Find the value of each variable. And even though it doesn't say, all of these are parallelograms. So we'll use the properties of parallelograms. For number 1, since this parallelogram has a right angle, then it has four right angles. That's one of the properties. So each angle is a right angle, which means that 3x has to equal 90. Divide both sides by 3 and x is 30. Since each angle is a right angle here, then 4y also equals 90. Divide both sides by 4, and y is 22.5. If a parallelogram has one right angle, then it has four right angles. On number 2, we're dealing with angle measures and side measures here. Look at the angles first. This parallelogram has a right angle, which means all four angles are right angles. So 6x has to equal 90. Divide both sides by 6 and x is 15. If a parallelogram has one right angle, then it has four right angles. Now look at the sides. Opposite sides of a parallelogram are congruent, which means that 8y has to equal 88. Divide both sides by 8 and y is 11. In a parallelogram, opposite sides are congruent, and if it has one right angle, then it has four right angles. Number 4. On this one, we're dealing with angle measures. In a parallelogram, opposite angles are congruent, but I don't want to say 3y equals 12x. I also know that consecutive angles are supplementary, and I do have two consecutive angles that just use an x. So those two angles are supplementary, which means that 6x plus 12x equals 180. Solve that for x. 6x and 12x make 18x. Divide by 18, and x is 10. Now since x is 10, I can substitute in for 12x, and that angle is 120 degrees. Since opposite angles are congruent, instead of saying 3y equals 12x, I can now say 3y equals 120. Divide both sides by 3, and y is 40. In a parallelogram, opposite angles are congruent, and consecutive angles are supplementary. Number 6. In this parallelogram, we're dealing with the sides, and opposite sides are congruent in a parallelogram. So I can say that 30x equals 150. Divide both sides by 30, and x is 5. The other pair of opposite sides is also congruent, but I don't want to say that 2y equals 72x. Instead, substitute the 5 in for the x, which gives you 360 for the bottom side. Opposite sides are congruent, so 2y equals 360. Divide both sides by 2, and y is 180. Opposite sides are congruent in a parallelogram. The diagonals of parallelograms have important properties as well. The diagonals bisect each other, so the two halves of each diagonal will be equal, and each diagonal separates the parallelogram into two congruent triangles, so you can use congruent triangle properties as well. Find the value of each variable. And once again, all of these are parallelograms. Number 1. In this parallelogram, the diagonals are drawn, and one of the properties of a parallelogram is that the diagonals bisect each other. So each one of those diagonals is cut in half. The two halves are equal. On one of them, 3x has to equal 12, because those halves are equal. Divide by 3, and x equals 4. For the other diagonal, since it's bisected, the two halves are equal as well. So 4y equals 8. Divide both sides by 4, and y is 2. In a parallelogram, the diagonals bisect each other, so make the halves equal. Here's a parallelogram with diagonals drawn. I know that the diagonals bisect each other, so the 2y and the 28 are the same, and the 4x and the missing segment measure is the same. And since we have two of the halves marked congruent, I know that their other halves also have to be congruent. The 2y matches the 28, so it gets a single hash mark. And the missing one and the 4x also get a single hash mark. So what we end up having here are 4 congruent diagonals. So let's solve. 4x has to equal 28. They each have a single hash mark, so they're congruent. Divide by 4, and x is 7. Since the diagonals bisect each other, 2y equals 28. Divide by 2, and y is 14. In a parallelogram, the diagonals bisect each other. Find the coordinates of the intersection of the diagonals of parallelogram ABCD with the given vertices. For number 7, we have the parallelogram with these vertices. So plot those points and draw the parallelogram. And if we're looking for the coordinates of the intersection of the diagonals, we have to remember the property of the diagonals of a parallelogram. And the diagonals of a parallelogram bisect each other. So if these diagonals are cut in half, then I need to find the midpoint of each diagonal. So let's draw the diagonals, and then we'll find the midpoint of each one. According to the graph, it looks like it's on the coordinates 3, 2. Now let's use the midpoint of each diagonal to make sure. For diagonal AC, let's use those coordinates to find the midpoint. X plus x divided by 2, y plus y divided by 2. That gives you the coordinates 3, 2. So it works out for that diagonal Now let's check the other diagonal. For diagonal BD, use those coordinates. X plus x divided by 2, y plus y divided by 2, 5 plus 1 divided by 2 is 3, 8 plus negative 4 divided by 2 is 2. So it works out. You can see from the way the graph is drawn that it's on the point 3, 2, and you can verify it by doing the midpoint of each diagonal. You do the midpoint because the diagonals of a parallelogram bisect each other, and that midpoint is at that intersection. This is lesson 6.3, Tests for Parallelograms. Your objectives are to recognize the conditions that ensure a quadrilateral is a parallelogram, and to prove that a set of points form a parallelogram in the coordinate plane. There are many ways to establish that a quadrilateral is a parallelogram. In the last section, we were told that it is a parallelogram, and if it's a parallelogram, then certain things are congruent and certain things are supplementary, like that. However, in this lesson, we don't yet know it's a parallelogram. So we're doing the questions in the opposite direction. Instead of saying if it's a parallelogram, then opposite sides are parallel, we're instead saying if both pairs of opposite sides are parallel, then it's a parallelogram. So you're saying the converse of these statements. If any of these situations is true, then it's a parallelogram. Both pairs of opposite sides parallel, or if both pairs of opposite sides are congruent, if both pairs of opposite angles are congruent, if the diagonals bisect each other, or if one pair of opposite sides is congruent and parallel, then it's a parallelogram. You only need one of those situations to occur, and the shape is a parallelogram. Find x and y so that the quadrilateral is a parallelogram. Even though we don't yet know that this is a parallelogram, we're going to make it a parallelogram. And the way the questions work is exactly the same way they worked in the previous lesson. So we have the side lengths on this one, and since we know that the side lengths need to be congruent for opposite sides, then it's a parallelogram. So we will make the opposite sides congruent. Start with the x's first. You have two opposite sides, 2x minus 2 and 12. Those are equal to each other. Solve for x. Add 2 to each side. Divide by 2. And x is 7. And now we need the other pair of opposite sides congruent, the 2y and the 8. To make 2y equal 8, divide by 2, and y is 4. So if x is 7 and y is 4, that makes opposite sides congruent, and it makes the figure a parallelogram. For number 2, we're given angle measures. Well, to be a parallelogram, both pairs of opposite angles need to be congruent. Let's start with the x's. 11x and 55 are opposites, so those have to be equal to each other. If both pairs of opposite angles are congruent, then it's a parallelogram. Divide by 11, x is 5. Now for the 5y, its opposite angle isn't listed, but we can find it because we know that the missing angle and the 55 degrees have to be supplementary. And 180 minus 55 is 125 degrees. So we need opposite angles congruent. 5y has to equal 125. Divide by 5, and y is 25. If both pairs of opposite angles are congruent, then it's a parallelogram. For number 4, I'm given one pair of opposite sides, and I'm given a pair of alternate interior angles. Well, that should be a clue. If they give you alternate interior angles, they're going to be talking about parallel lines. Remember one of the rules: if one pair of sides is both congruent and parallel, then it's a parallelogram. So consider the two lines cut by a transversal. Those alternate interior angles will need to be the same, and the pair of opposite side lengths need to be the same. Start with the alternate interior angles. 9x equals 45. Divide both sides by 9 and x is 5. That makes the two opposite sides parallel. Now to make them congruent, 6y has to equal 18. And when you divide by 6, y is 3. Make alternate interior angles congruent to get parallel sides, and make the side lengths congruent. That gives you one pair of sides that's parallel and congruent, which makes a parallelogram. Sometimes you work with parallelograms on the coordinate plane. On the coordinate plane, you can do the distance formula to find side lengths. You can do the slope to see if sides are parallel. And you can do the midpoint to see if the diagonals bisect each other. All of these can test to see if a quadrilateral is a parallelogram. Graph each quadrilateral with the given vertices. Determine whether the figure is a parallelogram and justify your answer with the method indicated. Number 1, it gives you the coordinates of the 4 vertices, and it says use the slope formula. Well, we need the slope formula to determine if lines are parallel. Parallel lines have the same slope, so let's find the slope of each side. If opposite sides have the same slope, then they're parallel. For sides A, B, and CD, we did the slope formula. M equals y2 minus y1 over x2 minus x1, and they each have a slope of 3. So they're parallel. For sides B, C, and AD, they each had a slope of 0, which is the same, so those sides are parallel. So both pairs of opposite sides are parallel. So yes, it's a parallelogram. Number 3 gives us the coordinates of the vertices, and it says use the distance formula. Well, the distance formula will tell us how long the sides are. Let's start with one pair, side RS and side UT. Side RS we can just count since it's horizontal, and it has a length of 4. Since side UT is diagonal, use the distance formula. The square root of x minus x squared plus y minus y squared, and that gives you the square root of 26. Since 4 is not the same as 26, then we don't have opposite sides congruent. So since opposite sides are not congruent, then no, it's not a parallelogram. Number 5 gives us the vertices, and it says use the distance and slope formulas. Well, distance will tell us if sides are congruent, and the slope will tell us if they're parallel. So the route I'm taking here is to see if one pair of opposite sides is congruent and parallel. So let's do the distance and the slope for sides SV and UT. When you do the distance formula, each of those sides has a distance of 5. So we know that the pair of opposite sides is congruent. Now let's do the slope formula to see if they're also parallel. When you do the slope formula, they each have a slope of -3/4. And since the slopes are the same, it makes them parallel. So we have one pair of opposite sides that is both congruent and parallel. Yes, it's a parallelogram.